Welcome back. Today we are going to solve a problem which is from target costing and transfer pricing limiting factor problem. Okay, yes, we'll start today. Haslin Company has the production capacity of 80,000 units. Okay, we'll slowly fill the informations. Production capacity 80,000 units. Current capacity utilized, which is 20,000 units. Selling price rupees 100 each. And then demand is very sensitive that every reduction in rupees 10 doubled of existing capacity. Okay, and then they have asked us to find out the total target costed to full capacity when profit margin is at 25 percentage, and cost reduction scheme at full capacity we have to find out, and then if at the present level 40 percentage of the cost is variable. Okay, 40 percentage of the cost variable, 60 percentage fixed. Total fixed cost rupees 36 lakhs, and then return on investment is 16 percentage. Maximum investment at full capacity we have to find out. Okay, so we'll solve this problem with if resist we'll solve this problem in 3 tables. Okay, very simple problem only. The thing is we have to priorly will be fix our selling price, but the market is fixing the selling price now because of the fierce competition in the market. Already products are there in the market, so we have to fix the selling price of the price of our product by the existing products in the market price. Okay, so that's what here is we are also doing. So we have to reduce the cost by fixing the target profit and target price selling price. Okay, so the first step is price at different levels. Cost reduction statement. Statement of maximum investment. Okay, so the first step is statement of demand and price. Selling price per unit, or instead of putting it here, we'll put the capacity first. Capacity units, selling price per unit, total revenue. Okay, 20, how much capacity is there first utilized is of 25 percentage capacity. Okay, 25 percentage capacity at 20,000 units. 50 percentage capacity doubled 40,000 units. 100 percentage capacity doubled 80,000 units. Selling price rupees 100. Every 10 rupees reduction, this increase in units is happening. So rupees 80. Right, this is what you have read here. Every 10 rupees reduces 2x of existing capacity will increase. Reduces 10 rupee reduce 2x of capacity increase. So multiply this 20,000 into 100, which is 20 lakhs. 40,000 into 90, which is rupees 36 lakh. 80,000 into 80, which is rupees 64 lakh. Yes, we have found out now. The second step is cost statement of cost reduction. Okay, particulars, present level 20,000 units, estimated level at 80,000 units, and then targeted level. Okay, 80,000 units. Just put per unit, total, per unit, total, per unit, total. Okay, what's the selling price per unit? Selling price is rupees 100 minus so profit at 25%. 25 is the profit. Total cost rupees 75. Right, that's what given in the question. Selling price is 100, 25% is the margin. So to total cost we have, in the total cost 40% is variable into 40%. So variable cost per unit is rupees 30. Now total variable cost, which is 6 lakhs. Then total fixed cost, how much given in the question? Total fixed cost, which is 36 lakh. Yes, what's the total cost? Which is 42 lakhs at the present level of 20,000 units. Now we have to follow the same set of cost structure for the estimated level. Estimated level, what we have estimated, rupees 80 will be the cost per unit. Cost price is sale price is fixed. What's the cost? Variable cost will be constant, and fixed cost also will be constant. Okay, so 30 into 80,000, which is 24 lakhs. Total this, which is 60 lakh, is the total cost of estimated level. You don't need to fill any other information, just this two information. Fixed cost is constant per unit. Total fixed cost is constant in total. That's what we have applied here. And then this is also rupees 80, but the profit is 25%. That's our targeted profit, which is rupees 20. Total cost is rupees 60. In this 24% is what? Sorry, 40% is what? Rupees 24, and then 24 into 80,000, which is okay. We don't need to do any of these things, because this is the targeted cost. This is our targeted cost. This is how we, within this we have to reduce our cost. Okay, so 60 into 80, how much? 48 lakh is the 48 lakh should be our total cost. Okay, so how much cost reduction has happened? Cost reduction is nothing but total cost of estimated level and targeted level, which is 12 lakh cost reduction has happened. This is the answer. That's it. We'll go to the third step, which is statement of max investment. Okay, step 3. Particulars, workings, total. What's the total projected sales? Total projected sales is 80,000 units into rupees 80, which is 64 lakhs. Okay, what's the targeted profit? Into 25 percentage, which is 16 lakh. Okay, divided by ROI, which is desired ROI, which is 16 percentage given in the question. Yes. Okay, 16 percentage. 100 lakhs is our max investment. Now the profit is, the formula is targeted profit divisible by ROI percentage. That's it. Okay. Yes. This is the problem. The first step, what we have to do is we have to calculate the demand at the, we have to calculate the price when demand doubles. Okay, and then we have calculated the total revenue also, and then we have to do the cost reduction part. Cost reduction part requires the present level of calculation. When we have a present level of calculation, we get the estimated cost level, and then we'll do the target level using the same structure. Okay, so the total cost and the target level cost reduction is the 12 lakhs that we have found, and then we have done the statement of max investment, which involves the projected sales. Projected sales is nothing but 80,000 into 80, which is 64 lakhs, and targeted profit is 64 lakh into 25 percentage, which is 16 lakh divided with the 16 percentage, which is 200 lakh. Okay, that's it. The next problem will go, which is from transfer price. Transfer price also involved with three steps. This problem is limiting factor problem. For limiting factor kind of problems, you can apply these steps. Step 1, step 2, step 3. Just calculate the contribution per limiting hour and rank it, and then calculate the total required hours. Step 1. Step 2 is calculate transfer price, minimum transfer price in case of short hours, minimum transfer price in case of excess hours. In this problem, this is how this the structure will be. You will get to know when we start solving the problem. Okay, what they have given, division A is the profit center and it has XYZ. Okay, external market also there. External market, they have given the units, and variable cost also they have given, and the labor required for unit also given. Product Y is transferred to division B. Another division introduces maximum quantity that B required for transfer is 300 units of Y is required by division B internally. Okay, for that only we have to find out the transfer price. And the external sales is 800 units, 500 units, 300 units. Okay, they have even the demand also. And instead of receiving transfers of product Y from division A, B could also buy the similar product in the market as the slightly cheaper price of rupees 45 per unit. Okay, calculate the transfer price of for each unit if the uh, total labor hours available in the division is 3,800, 5,600. Two cases they have given. What if we have only 3,800 hours of limiting factor, and then what if we have only, what if we have more than the required level of which is 5,600 hours in the production level. Okay, that we'll find out quickly. The first step is statement of ranking and total required hours. Particulars rupees x y z. What's the selling price per unit? Selling price unit is 48, 46, 40 minus variable cost per unit, which is 33, 24, 28. What's the contribution per unit, which is 15, 46 minus 24, which is 22, 40 minus 28, which is 12, divided with limiting factor. What's the limiting factor? Hours is the limiting factor. What's the labor required per unit? 3 hours required for product X, 4 are required for product Y, and 2 hours required for product Z. What's the contribution per limiting hour, which is rupees 5 per hour, rupees 5 per hour, 22 divisible by 4, which is rupees 5.5 per hour, and then 12 divisible by 2, which is rupees 6 per hour. Rank it 1, first rank, second rank, third rank. Okay, now we have to find out the total hours required. Okay, first, what's the demand? We have ranked it. Now what's the demand? Demand is 800 units, 500 units, 300 units. Total hours required. What's the total hours required? This is the total hours required per unit. Okay, multiply these both things. Okay, 800 into 3, which is 2400 hours. 4 into 500, which is 2000 hours. 2 into 300, which is 600 hours. Total hours 5000 hours. Okay, 5000 hours totally required. We have given it two situations: shortage of hours and excess hours. Okay, this is what I have given. So we have found the first level. Then we'll go to the second, which is calculation of transfer price when shortage of hours, which is 3600 hours, right? Yes, 3800 hours. Sorry, 3800 hours. Particulars, workings column here, it will be helpful for us. Rupee per unit total. Okay, now what's the variable cost per unit? Variable cost for YA Variable cost for Y is 24. How much units we have to give to division Y, which is 300 units. 300 into 24, which is 7,200. Then comes okay, in case of shortage of units, see, this is the second rank. Why is the second rank product? We also have three. So if what's that, if division another division is asking, no, we should not utilize this level. This is the higher contribution area, we have to touch it, this part we have to sacrifice this X level, and then from this we have to produce Y. So what's the opportunity cost here? How many units we need to produce in produce for division Y, which is 300 units, no? So 300 units into how many hours, which is 4 hours, 1200 hours required, with that has to be sacrificed by division X. Okay, what's the contribution per limit per hours, which is rupees 5 into rupees 5 per hour, which is how much? 1200 into 5, 6000. 6000 divided by 300, which is 20. Okay, so this is how we have to calculate. What's the minimum transfer price? Rupees 44. That's it. We'll go to the last step, which is same in case of excess. Particulars, workings, rupee per unit, total, which is variable cost per unit, opportunity cost, excess. Okay, opportunity cost, sacrificed. Okay, so in case of 5600 hours, external market is 5000 hours only, so we can freely transfer 600 hours to the another division at no opportunity cost level. Okay, so what's this? This will be same 24 per unit. Variable cost doesn't change. Okay, so 7200. There is no opportunity cost for extra 600 units. Okay, no opportunity cost, but another 600 units we have to transfer from any of the least contribution giving product, which is A only. So 600 into 4, sorry, 600 into 4 per 600 units into 4 hours, how much? Sorry, 300. This is not units, this is hours. Okay, so we already have 600 hours extra in this, into rupees 5 per hour, 3000 divisible by 300 units, rupees 10. What's the minimum transfer price? Rupees 34. That's it. Okay, I hope you guys have understood this problem and this structure. We'll solve the other problem tomorrow. Thank you.